Sometimes when doing math, you just need a big warm hug. And to do more math. So, welcome to Check on Learning in the 1.4 style. So, yeah, 1.4, Check on Learning. Oh, look, only 4 problems. Ooh, easy. Let's do it. So which of the following characteristics of the parent absolute value function and the parent quadratic function will allow you to distinguish between the two functions without drawing their graphs? Explain. The blank are different for the two functions. Okay, what is different? Vertex is the same. Reference points, I think, might change. Average rate of change, that's definitely different. We'll do that. Is different for the two functions. This characteristic is constant for each branch of the parent absolute value, because remember the absolute value is a straight line, but is not constant for the parent quadratic, because it's a curved line. It's not constant. I like it. Eventually, I'll actually have the answers, and I can check them. Until then, you'll just have to trust me, I guess. I don't know. Extra credit points for somebody who finds mistakes, I guess. I don't know, maybe. A function is described h of 1 equals that. Use a vertical transformation of the parent absolute value function to write the function h2 of x that has the same graph as h1 of x. Use a vertical transformation I would say if we just a vertical transformation in this situation, we can just pull that 1/6 out and it would turn into a vertical transformation as opposed to a horizontal one here. And the reason I think I can do this is, so if you think about it, right here, our function or our graph is going to look something like, so let's see here, 0, 0, if x is 1 or -1, y is going to be like 1/6, which is not a lot, which is like right there. So it's going to be a really flat whatever. So that is a horizontal stretch. Well, we could also do the same thing by squishing the absolute value function vertically. So I would say the answer would just be 1/6 times the absolute value of x. And again, because, I'm sorry, not 1/6. Yeah, 1/6. So it's a stretch when it's going horizontal, but to get the same effect, we're squishing it or we're compressing it vertically. So in a sense, they do the same thing. Oh no, my face is in the way. It's a weird question. It's a good one, but it was a weird one. The graphs of f and g are shown. Yay. State the function g of x, that's the blue one, as a transformation of f of x. That's the black one. So, step 1, let's figure out our parameters, because they're a little bit easier to see. So, the first thing I like to look at is, well, let's zoom in, are the vertex, or vertexes, I don't know. So, g of x, well, whatever, we'll just label our parameters and I'll throw everything in an equation later. So it went to the right, 1, 2, 3, 4, right? Those are all 1s. I sometimes get my scales mixed up. So it went to the right 4. So our k is going to be equal to 4. No, false. Our h is going to be equal to 4. And then our k is going to be equal to 1, 2, because it moved up 2 units. Okay? So now our reference point went from being 1, 2, 3, 4 units up to being 1, 2 units up from the vertex. So we're going to say that's a vertical squish. Yeah, that's what I'm going to say. I'm going to say it's a vertical squish, or compression is the actual word that I'm supposed to use. A vertical compression. So that means it's going to be on the outside. That means that it's going to be A. A is not negative. There's no reflection. And it's a compression by 1/2. So it was out here, and then I think 3, 4, 5, 1, 2. Oh no. Oh yeah, so it was 4 units up on the big one, and it's only 2 units up, so it got cut in half. So my final answer is going to be, I knew they were going to give me all these spots. Hey look, it even gives me an A spot right there. A is going to be 1/2. I'll get my chicken scratch out of the way. 1/2. F of x minus h, which is 4, plus 2. All right, so here I am on item 3. I'm looking at the answer right here. They have a 2 out front instead of a 1/2. I can't for the life of me figure out why they would have a 2 rather than a 1/2, because the black parabola is being compressed with respect to the reference point here. Like, it's getting closer. It's not getting stretched. So I'm going to go with they're wrong. You know, whatever. But if for whatever reason you really need to see the green check marks, there's your answer for that. Anyway, moving right along to number 4. Yay, trigonometry! Actually, it's probably not trig yet. I'm just kidding. Sam is using a laser pointer to measure the height of a building. That's neat. The laser pointer is aimed at a mirror placed on the ground so that the light beam reflects off the mirror up to the top edge of the building's exterior wall. The beam can be modeled by an absolute value function where x is the distance from the exterior wall of the building. Okay. So I guess he's up here, pointing it down. There's a mirror, and it's bouncing off. Okay, sure. State the function that models the path of the beam from the laser. Include the domain and range as compound inequalities in terms of x and h. Give exact values. Do not round. That means we're probably going to have some fractions. So, h of x. So let's see here. They said it was an absolute value. So our parent function is just that. So you'll notice that our vertex was at 0, 0. Let's zoom in. And now the vertex has moved to 22.5. So it was a horizontal movement to the right. So now our new one is going to be x minus 22.5. because our h in this case was 22.5. Our k is 0. And so we can then use this number to figure out our A, since they gave us that point. So here we go. So that means we're going to have our g of x. Well, we'll just go ahead and plug everything in. So our y, or our g of x, is equal to 5, equals our x is going to be 26.25 minus 22.5. Oh, and there's an a out here out front. I forgot about that. So then that means our 5 is equal to a, and I'm changing that parentheses because I'm doing the math in the inside of there. Go away, face. You're in the way. 26.25 minus 22.5. I'm so good at basic arithmetic. I'm sure most of you probably figured that out in your head. If you did, great. I'm proud of you. If you didn't, that's okay. We can be bad at arithmetic together. So then we're going to divide both sides by 3.75. So that means that our A is going to be equal to 5 divided by 3.75. We're going to turn that into a fraction, which, by the way, 0.333333 is 1/3, so that's 1 1/3. But just so you can see how to do it on the calculator, and I never trust myself, I just shove it back in there. So A is equal to 4/3. So our total final equation is g of x, or whatever it is that they're using, is equal to 4/3 absolute value of x minus 22.5. Whee! Okay, let's see what they're asking now. State the function that models the path of the beam. That's this part right here. So 4/3 absolute value. Make sure you hit the X, not the times button. X minus 22.5. The domain is going to be 0 to 26.25. So I'm assuming they want this in interval notation. Maybe not. Let's check. They want it in no. What are these called? Inequality form. That's it. So the domain, the interval, is going to be 0 is less than or equal to x, which is less than or equal to 26.25. And I'm getting that number from right here because that's the information that we have. What was it? 26.25 or something? Yeah. 0.25. And then our range is, again, from 0 to h, whatever that is. So our range is 0 less than or equal to are we still using our x? Or are we using our h? Yeah, that's our h. Did they tell us the height of the building? Did they tell us the height of the building? No, they did not. But we can just figure out the height of the building by shoving 0 into our function, and that becomes 22.5 times 4 over 3. So 22.5 times 4 over 3. So that's 30. And it's less than or equal to 30, because that's our height of the building. Now I can get rid of my chicken scratch. Part B. The units on the diagram are in feet. What is the value of h of 0? Well, we just did that one. So that's what I shoved into my calculator right there. And so the value of h of 0 is the height of the building, which is 30 feet. And then just in case you don't believe me, again, here are the answers. So there you go. Check on learning complete. Good job. I will see you in class. I'm pointing at the screen, but you guys can't see my face, so whatever. Bye-bye now.